Recording's rolling. It's Thursday, October 23rd. We're going to do a turntable friction lab today. You guys remember last week you guys had this lab? Okay. So it's the same page just on the back side. I'll have you guys turn this in by the end of class today, and then I'll put both grades into the grade book so you guys have those. Okay, then your guys' textbook puzzles, which we've been working on a little bit here and there. I think I'll do a couple more with you guys tomorrow and maybe another activity, and then I'll have you guys turn those in tomorrow. Okay, so hold on to what you got so far, and then have you guys turn those in tomorrow. I'll take home quiz I gave it to you guys yesterday, so remember that's due Monday. So you guys give a lot so far. Okay. Also, tomorrow is a pep rally day and a pep rally schedule, so all the classes are shortened by a few minutes. So just be clear about it. And so what's going on with this? What I want you guys to do is figure out what is the coefficient of static friction between. Oh, here, guys, it's right here. Here's the question. Let me hold this up to the camera so you can see it. Okay. So here's the setup. We got a turntable. We got some coin on the turntable. What's the coefficient of static friction between the coin and the turntable? Okay, so give you guys a demo here. Okay, so basically, it's right here. Let's say I'm going to use Roosevelt. Let's do Roosevelt right here. So give Roosevelt a spin. Now, guys, if there was no friction, then wouldn't Roosevelt just like slide off? Okay. Or actually, you would never move at all. You just kind of hover there. But if there's a little bit of friction, you'd probably slide off pretty fast. Okay. But there's significant enough friction to hold them in a circular path. Guys, what if I spin it a little faster? A little faster. A little faster. You guys think at some point, whoop, there goes Roosevelt. He's going to slide off. And if I know what angular speed that is right there, where he was sliding off, then do you think that in principle I could determine how much friction, like the coefficient of friction between those two surfaces? Something like that? So, oh, here's the process right here, right? Which I also gave you right here. You guys see above this last column? Okay. So this process is this process. It'll lead straight to the necessary coefficient of friction. Okay. So if you're looking for like a minimum necessary coefficient of static friction, this could just become an equal sign, and you got it. Okay. But you have to know some things. You have to know, ooh, where did I place Roosevelt? Notice I just plopped him on here. Could you guys take your ruler and measure the distance to where Roosevelt or your point? Okay. Because see, guys, what if I had him really close to the center? We have to spin this really, really, really fast. Like he's not even moving. Well, there's no radial change. Okay? But if I had him on the outside edge, he'd fly off real fast. Okay. So the location, guys, I think the location that you park that point matters. Uh, can you guys pick your favorite value of Earth gravity today? Either 9.8 or 10 meters per second squared. Okay. And this angular velocity, right. Well, guys, if you see it spinning, how do you think you can determine how fast it's spinning? Okay. Remember, you're looking for the angular velocity at the point that the coin breaks friction and slides off. And if you can somehow maintain that angular velocity, can you guys think of a way to do that? Huh. Right. Might have something to do with these other columns in this table. Look at this table. You might get a hint here. Okay, so, okay, you got different trials. Maybe you try a few trials, maybe take an average at the end. Oh, I actually did give you guys gravity field in centimeters per second squared. So if you want to use the unit centimeters, then that would be the corresponding number for the gravity field. What's the radius in centimeters? Oh, there's one revolution. How many radians is that? 2 pi, which I did give you. Maybe that's helpful somehow. Oh, time, stopwatch. Do you think you could time maybe how many revolutions it does and how much time? Oh, that could somehow lead to getting angular velocity, couldn't it? Right? If you know revolutions per time, right? Because if you pop a number here, do you want to do revolutions per second? Is that the unit you want? You don't want revolutions per second. You want what? Radians per second. Can you guys put a numerical value in here that's radians per second? Okay. Um, Right. So again, the process on the poster is the same as up here. Don't worry about writing procedure. Really, the right half page I just gave for my AP students. Remember that. Okay. Right. So you guys see the box of turntables up here? And right next to it is a small box of stopwatches. You guys see both of those? Turntables, stopwatch? Okay. So here, I give you guys a setup. Remember, your goal is to figure out what's the coefficient of static friction between, say, like this coin and the surface. Okay? And yeah, I'll let you guys apply some critical thinking today. So I'm going to leave this up here, and I will walk around the class and help you guys, and just turn this last page into the grade tray by the end of class.